Hello and welcome to this lecture. Today we are discussing about the operation principle of solenoid actuator in the term of energy conversion. My name is Payam Shams Kahfarouhi. Please follow me during this lecture. The outlines of this lecture divided to three important parts. First started with the introduction about the energy conversions, and then we will look at the deeper fruitful in the solenoid actuator, and then describe it the energy conversion process in the solenoid actuator. The goals of this lecture is divided to three main parts: to understand the electromechanical energy conversions, and then understand the operation principle of the solenoid actuator, and finally understanding the electromechanical energy conversion in a solenoid actuator as a singly excited system. As an introduction, first we have to answer the question, what is the electromechanical energy conversion? So, a conversion of electrical energy into the mechanical energy, or vice versa, with the aid of rotary motion or linear motion, is called electromechanical energy conversion. You can see also in the picture that electrical mechanical converters with the aid of motions can transfer the mechanical or electrical energy input to the electrical mechanical energy output. To become more clear, I'm going to show some example about the electromechanical energy conversion devices. First, the machine and devices that converting the mechanical energy into the electrical energy. As you can see in this slide, the windmills or wind generators converted the mechanical energy from the wind to the electrical energy comes from the generator. And also in another pictures you can see the steam generators that changing this mechanical energy to the electrical energy. Here in this slide you can see the example of the electrical machine energy conversion devices that can convert the electrical energy into the mechanical energy. So in the first you can see the electrical drill that changing the electrical energy to the mechanical energy, also the electrical motors and the ceiling fans. However, for further discussion about the energy conversion process in the electromechanical devices, we are going deeply to understand the principle or operation principle of the solenoid actuator. So what is the solenoid actuator? So solenoid actuator is some kind of valve that when the current carrying inside the solenoid coils is energized, produce the magnetic field. So as the magnetic field strength is powerful inside the solenoid coils, so the cylindrical plunger move and compress the springs, and the fluid flow can pass from the valve. As you can see, this fluid can be the water or even fuel for the combustion engines. When the current stops, then the compressed spring expanded and push the cylindrical plunger move to the same places. These valves are normally closed. Now we will focus on the energy conversion process in the solenoid actuator. First of all, we have to be clear that the main principle of conversion energy is that energy can neither be created nor destroyed. It can only be changed from one form to another. Therefore, total energy in a system is a constant. An electromechanical converter system consists of three essential parts. The first one is the electrical system that here in the solenoid actuator is a solenoid coils produces the magnetic fields, the main magnetic fields, and the next one is the magnetic system. That magnetic system or the magnet is the medium of energy conversion, uses as a medium of the energy conversion. That is the fluxes or the magnetic field in the magnetic core or air gap. Then the next one is the mechanical system, that here is the plunger and springs. So in this system, the energy transfer equation is as follows: that electrical energy input from the source is equal to the mechanical energy of output plus increased the stored energy in the magnetic field and the energy losses. As you can see in the diagram, the losses included in the electrical system, that here in the solenoid coils, we have a electrical losses consist of the resistive or coupled losses of the coils, the magnetic losses included the field losses, and the mechanical system, that it is a friction and windage losses. As it mentioned, the solenoid actuator is a singly excited system. So we are going to describe the one simple singly excited system. So according to the energy balance, the energy transfer equation can be rewritten as that electrical energy input from the source minus the losses comes from the resistance losses equal to the mechanical energy output plus friction and windage losses and plus increasing in the stored field energy plus core losses. So for analyzing the model, I'm going to divide the section to three parts. First, going to describe the electrical input energy. For this one, by using the KVL or Kirchhoff voltage law, defining that voltage, the total power supply voltage, equal to the sum of the EMF plus the losses resistance or the resistance of the coil multiplied to the current path through them. The EMF or the voltage induced can be calculated by the Faraday law as equal to the number of the turns to the changing of the flux per time. By replacing the equation number 2 in equation number 1, we get the equation number 3, and then simply we can calculate the power. That power is equal to the voltage multiplied to current. So we are multiply the current in the both sides of the equations. Then we have voltage multiplied current equal to the power losses and plus N multiply I d phi dt. However, we can define it the work equal to the power multiplied time. Therefore, we multiply both of them to the dt, both of sides of the equation to dt, and then we get the amount of the electric work that's equal to the NI d phi. For the mechanical energy, we have two factors. One of them is force, and the amount of the other one is the distance of moving plunger. That is equal to dx here. So the work or the mechanical work is defining as a force multiplied to the distance of moving plungers. But for energy stored in the magnetic field, we have two conditions. If the mechanical output energy or plunger movement is 0, then the mechanical work is equal to 0, and based on the correlations defined by the energy balance, the electrical work will be equal to the amount of the energy stored in the magnetic field. However, if the plunger moves the distance dx in the direction of the force, then the amount of the energy stored energy in the field can be calculated by the differential of the input electrical energy and mechanical one, and by replacing the data comes from the previous equation, we reach to the final equation for the amount of the energy stored in the magnetic field. Thank you so much for your attention. Hopefully that you will get you use these informations, and this lecture will be useful for you. If you have any questions, please write in the comments. I will answer it as soon as possible. Have a nice day. Bye.